Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this deep dive into Apache Vysper. In today's video, we're going to explore Apache Vysper, a lightweight XMPP server designed for embedding in Java applications. Unlike traditional XMPP servers like Jabbird or OpenFire, Vysper is built to be integrated directly into your codebase. This makes it perfect for scenarios where you need fine-grained control over XMPP behavior or want to avoid the overhead of a standalone server. We'll walk through its architecture, key features, and how it compares to other XMPP solutions. Before diving into Vysper, let's quickly cover XMPP. XMPP, or Extensible Messaging and Presence Protocol, is an open standard used for real-time communication. Originally developed for instant messaging, it has evolved to support presence information, data streaming, and even EOT communication. XMPP is XML-based and highly extensible through XMPP Extension Protocols, or XEP. This flexibility makes it a powerful choice for custom communication solutions. So why would you choose Apache Vysper over other XMPP solutions? First, it's designed to be lightweight and embeddable, meaning it runs within your Java application rather than as a standalone server. This is especially useful for enterprise applications or EOT systems where you want tight integration. Vysper is written in Java, so it integrates seamlessly with Java-based projects. Its modular architecture allows developers to enable or replace components as needed. Plus, it's open source under the Apache license, giving you freedom to use and modify it. Apache Vysper supports the core XMPP RFCs, including RFC 6120 for core protocol and RFC 6121 for messaging. It provides standard features like presence and messaging out of the box. Additionally, it supports key XMPP extensions like multi-user chat MUC and publish-subscribe pub/sub. One of its strengths is its pluggable architecture, which allows developers to swap authentication systems, session handlers, and even core components. This makes it highly adaptable to various use cases. Let's take a closer look at Apache Vysper's architecture. At its core, Vysper follows a modular design where different components handle specific aspects of XMPP communication. The core server is responsible for stanza routing and session management. You can plug in different authentication modules or write your own. Handlers for specific XMPP features like presence or messaging can also be customized. This architecture makes it easy to tailor Vysper to your exact needs. Security is a critical aspect of any communication system. Apache Vysper supports multiple authentication mechanisms, including SASL and custom authentication modules. You can integrate it with existing user databases or even external systems like LDAP. Transport Layer Security (TLS) is supported to encrypt communication between clients and the server. Additionally, Vysper allows fine-grained access control and integrates well with Java's built-in security frameworks, making it suitable for enterprise environments. One of Vysper's standout features is its extensibility. You can write custom stanza handlers to support new XMPP features or business logic. Its plugin architecture allows you to enhance functionality without modifying core code. Vysper also supports custom XMPP namespaces, enabling you to define your own extensions. Integration with external systems is straightforward thanks to its event-driven programming model and Java-based APIs. Setting up Apache Vysper is straightforward for Java developers. First, you'll add Vysper's dependencies to your project using Maven or Gradle. Next, you configure the server either programmatically or through XML configuration files. Then, you initialize the server components in your Java code and start the server, binding it to the appropriate network interfaces. Finally, you can test it using XMPP clients like SMAC or PSI to ensure everything is working as expected. Let's look at a real-world use case, EOT communication. In an EOT network, devices often need to communicate in real time. XMPP is a great fit due to its lightweight nature and support for pub/sub patterns. Apache Vysper can be embedded in a central EOT gateway, handling authentication for device identities and routing messages between devices. Using XMPP pub/sub extension, sensor data can be efficiently distributed to interested parties. This setup is both scalable and secure, especially when combined with TLS encryption. When it comes to performance, Apache Vysper is lightweight by design, making it ideal for embedded systems and custom deployments. However, its performance can vary depending on the number of active sessions and the modules you're using. Tuning JVM settings can help optimize memory and CPU usage. While Vysper isn't designed for massive scale out of the box, it's a solid choice for medium-scale deployments where customization and integration are priorities. How does Apache Vysper compare with other XMPP servers? Compared to Jabberd, which is standalone and Erlang-based, Vysper is embedded and Java-based. Against OpenFire, which offers a rich admin UI, Vysper trades that for deeper Java integration. Prosody, written in Lua, is lightweight but lacks Vysper's Java ecosystem integration. Vysper shines in customization and embedding scenarios, but may require more effort to scale compared to Jabberd or OpenFire. While Apache Vysper has many strengths, it's not the right choice for every project. If you're building a large-scale public XMPP service, you might want to consider a Jabberd or Prosody instead. Vysper requires Java expertise to fully customize and tune. Its community is smaller, so documentation and third-party support are more limited. For high-performance or public-facing deployments, additional tuning may be necessary. It's best suited for internal or embedded use cases where Java integration is key. To get the most out of Apache Vysper, here are some best practices. Only enable the modules you need to keep the server lightweight. Implement proper logging and monitoring to track performance and troubleshoot issues. Always secure communication using TLS. Customize authentication to fit your application's security model. And finally, test thoroughly with real-world load scenarios to ensure reliability and performance. Looking to dive deeper into Apache Vysper? Start with the official Apache Vysper website and documentation. The GitHub repository contains the source code and several examples to get you started. You can also join the mailing lists for community support. Pairing Vysper with the SMAC XMPP client library can help you build complete solutions. While community resources are limited, there are third-party tutorials and blog posts that can provide additional insights. In conclusion, Apache Vysper is a powerful tool for integrating XMPP capabilities directly into Java applications. Its modular design allows for extensive customization, making it ideal for embedded systems and custom communication solutions. However, it does require Java expertise to fully utilize and may not be the best fit for large-scale deployments. Before choosing Vysper, consider your project's scale, customization needs, and available expertise. If you're building real-time communication into a Java app, Vysper is definitely worth exploring. If you found this deep dive into Apache Vysper helpful, give it a like and subscribe for more tutorials on open-source technologies. Drop a comment with any XMPP or Java questions you have. We'd love to hear from you. Don't forget to check out the links below for related content. Thanks for watching, and we'll see you in the next video. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.